Hello everyone, I am Professor Anis Vora and I welcome you all in this video lecture. In this video lecture, we'll study about 4-bit parallel binary adder as well as 4-bit parallel binary subtractor. First, let us start with 4-bit parallel binary adder. In case of half adder, we know that we can add 2 binary bits at a time. In case of full adder, we know that we can add 3 binary bits at a time simultaneously. So, in case of multi-bits, for example, let us consider 4 bits. Suppose we have A0, A1, A2 and A3. We have 4 binary bits. A0 is least significant bit and A3 is most significant bit. We do the addition with another 4 bit, that is B0, B1, B2, B3. And we have a summation, that is S0, S1, S2 and S3. At a time, we can have a carry also, and that is C1, C2, C3 and C4. So now to implement this 4-bit parallel binary adder, we require 4 different full adder, or at the most we require 3 full adder as well as 1 half adder, because at the least significant side, when we start, there is no possibility of the previous carry. So at the first stage, we can use a half adder. Now let us start implementing the block diagram to understand the 4-bit parallel binary adder. We have 1 half adder for the least significant bit. We have A0 and B0, and we have summation of A0 as well as B0, and that is S0. We have another full adder. Now from second stage onward, we'll have to take a full adder, because there is always a possibility of the carry, and with the 2 binary bit we can have to add a carry also. So from the first stage, if carry is generated, then it will have to transfer to the second stage, and now this is known as a cascading of the adders. We have A1 and B1, that is a second binary bits. We have summation of A1, B1 as well as if there is a carry C1, and summation is S1. We have third full adder. Again, if the carry is generated from the second stage, that is C2, and that is transferred to the third full adder. We have another pair of inputs, that is A2 as well as B2, and we have a summation, that is S2, and that is summation of A2 plus B2, and if there is C2 also. We have last stage, and that is full adder. Again, the carry generated from the third stage, that is transferred to the last stage, and that is C3. We have another pair of input, A3 and B3, and we have summation S3, and we have a last carry output, that is C4. So this way we can implement 4-bit parallel binary adder with the help of either 3 full adder and 1 half adder, or we can use 4 full adders. Now let us study 4-bit parallel binary subtractor. We have 4 bits x0, x1, x2 and x3, and we want to minus another 4 binary bits, that is y0, y1, y2 and y3. And we have a difference, that is d0, d1, d2 and d3. In some of the case, we have to take a borrow. So we consider borrow, that is b1, b2, b3 and b4. Now let us implement a logic circuit with block diagrams for 4-bit parallel binary subtractor. At the least significant side, we can use a half subtractor also, because there is no possibility of the previous borrow. So we can use half subtractor also at the least significant side. But if we use a full subtractor for the first stage, that is our least significant bit, then input borrow that we have to ground, because otherwise it can take a very unpredictable input. So B in, that is borrow in, that we have grounded. We have pair of input, that is x0 and y0, and we have a difference, that is d0. We have a second full subtractor. We pass the borrow, that is b1. We have another pair of input, that is x1 and y1, and we have a difference d1. We have third full subtractor. We pass or cascade the borrow, that is b2. We have next pair of input, that is x2 and y2. We have difference, that is d2, and we have last full subtractor for the most significant bit, and we transfer borrow b3 to the last full subtractor. We have last pair of input, that is x3 and y3, and we have a difference, that is d3. At the same time, we have final borrow, that is b4. So this way, with the help of 4 full subtractor, we can implement the logic circuit for the 4-bit parallel binary subtractor. Thank you very much for watching my video. Keep watching. Thank you very much.